We're here at the ITU studio in Geneva, and I'm very pleased to be joined by Thomas Wiegand, who is an expert in the field of standardization for multimedia. Mr. Wiegand has played a key role in the development of ITU-T H.264 AVC video coding standard, which won a Primetime Emmy Award from the Academy of Arts and Sciences in Los Angeles, and he's also helped to develop its successor, ITU-T H.265 HEVC. Mr. Wiegand, thank you very much indeed for being with us today.
Thank you.
Now, you're here in the studio because you've just been awarded the ITU 150 award, and you're collecting it, I know, on behalf of the team that produced this incredible video coding standard. I'd like to ask you, what does the future of internet-based video applications look like?
Well, thank you. First of all, I'm deeply honored, and we all are very happy that the video coding work has been recognized by ITU as one of the most influential ICT innovations of our time. The number of bits on the internet is growing, and the main driving factor is internet video. There is a paradox in place, which is the better we compress, the more bits are being transported.
And very much, obviously, H.265 is going to compress those bits and make them much more easy to transport than ever before.
Yes, H.265 or MPEG HEVC has been a joint effort between the ITU and the ISO, by the way, is going to be about 50%, it's going to be using about 50% of the bits of H.264 MPEG AVC. And given that half of the bits are probably formatted on the internet with the old standard, HEVC will have a bright future.
Now, your work on H.264 impacted the industry enormously. It's being used in many of the videos we watched today, as I just mentioned. What was the motivation behind working as an academic contributing to ITU?
As an academic, you have research ideas and you want to bring them forward, kind of your babies, and you want to see them grow and become adults. And the standardization platform is an amazing platform. If you think that something that you produced on the whiteboard and then on paper and then a computer with math, etc., ends up in about 3 billion devices at the end, that's an amazing opportunity as an academic to bring things forward.
So every time you're watching a video on the net, on the web, etc., are you thinking, I played a small part in that?
At the beginning, I was kind of looking around, like where can I find these devices and etc. etc. But now the impact has become so big that have passed that stage and very happy.
It's also extremely important for education as well, for distance learning and that kind of thing. I think it's enabling people to be aware and taught of all sorts of different subjects and at a distance where they wouldn't have been able to access that kind of information before.
Yeah, the team that worked on the H.264 MPEG AVC standard was very lucky. They were at the right moment when the throughput on the internet became big enough so that we could share videos everywhere. You have sharing of user content, you have education and video type communication, distribution. And so when you do something that has an impact, that is technologically better, and you are coming in at the right time, when smartphones became available, when flat panel displays became available, then you can reach such a big success.
So using a crystal ball or a mobile phone, looking into the future, what do you think that the video codecs will be like in the future?
We are just at the beginning. When it comes to exploiting the human visual system, so about 30% of your brain are used by the visual cortex in order to process pictures. So far, our codecs have only used the optical system of the eye. The things that happen in the brain haven't happened yet. There's an audio coding standard that has the popular name of MP3. You may have heard of it. MP3 uses perceptual methods in order to lower the bitrate at the same perceived quality. And we are in video coding prior to the MP3 stage. So we have a bright future ahead of us. There's all sorts of things that can be explored, like wall-size displays or three-dimensional autostereoscopic displays. So no need for eyeglasses, just three-dimensional displays. And all sorts of other things that we will see in the future. So video has just started.
Holographic?
Yeah, if that's the right way of doing autostereoscopic, holographic would be great. Yeah.
Brilliant. Okay, well, Mr. Wiegand, I just finally want to ask you really just the public recognition of the IT 150 award. What does that mean to you?
I was very surprised and deeply honored to be the one to receive it. It has been a team effort, and a big team has worked on it. And I want to say to everybody, you should put it on your webpage, because you're also receiving this award if you worked on these standards. So it's a great thing. We are very happy to be recognized with our work as time goes on. And I want to in particular mention Gary Sullivan, who now for a quarter of a century has been working on this. He brought me into the subject, and he should deserve a special mentioning here, because he is the one driving it, and without him we wouldn't have gotten where we are.
Thank you very much indeed, and congratulations.
Thank you.